Okay. Now, the second session, the second part is how to deploy the Hyperledger Fabric in a clustered environment. Again, I would like to demonstrate because normally when you deploy, sometimes it's much easier to use the cloud platform. Cloud platform is Google Cloud, maybe IBM or Oracle, but most cases they're actually very expensive. So if you already have an existing hardware, or we call the bare metal, or maybe a third-party cloud platform, you can actually set up the cluster on your own without the point and click. Now, the most important part is when you deploy a cluster, there are two things that you need to do. Uh, First is the what we call uh, the preparing the hardware or preparing the servers. Like if you plan to create a cluster with one master node and three worker node, that means you need to set up four virtual machines. It doesn't have to be a virtual machine, but it could be a physical server. But you have to do normally you have to do it manually. But now there is another technique. We call them the uh, Terraform. Let me demonstrate.
Okay.
Terraform. So this is a very popular client written
Okay.
by HashiCorp. So the purpose of this is to actually prepare. So remember, there are two stages uh, for creating the automation. First is you set up the hardware, and then second is you deploy the cluster, meaning cluster deployment. So Terraform is a script that allows us to actually automate everything. So let me demonstrate how this can be done. Okay. Let me know if you can see my screen.
Yes.
Okay. So first is we will set up our hardware, but we don't want to deploy it manually or create the system manually. So in Terraform, we will configure what we call a deployment plan. Let me show you. Okay. So if you can see on the screen, we created a deployment plan that allows me to deploy a one single CPU with a 2 gig of RAM.
Mm-hmm.
Has one master, you can see here, and
Right.
three worker node, one, two, and three. So all I
Okay.
have to do is just create the deployment plan, and then Terraform will do everything automatically for me. I just need to define like this size is 100 MB, 2 gig of RAM. So sorry, very low power system, but this is just to demonstrate. So one
Mm.
CPU, 2 gig of RAM, and 100 gig of this size. One master node and three worker node. So now let me try to deploy, and I will demonstrate how system can be automatically deployed. Okay, but first, before that, let me show you because I don't have a bare metal. So I will show you a cloud account. If you look at right now, it doesn't have any deployed virtual servers. It's empty. Okay. So what
Okay.
I will do instead of manually, like I can deploy server one, deploy here. Everything is manual. We automate. So let me show you. So right now it's empty. Now I will execute the deployment plan that I have originally created. So let me do that. So I say Terraform, and then I will apply. The cluster settings is the file that I've shown you, Babi-san, deployment plan, where I have 1 gig of RAM, 2 gig of 1 gig, 1 CPU, 2 gig of RAM. Then I will tell the system to actually save the state like that. Okay. So I will automate, and I will show you also. Okay. Sorry. I missed something. Okay, I'm missing something. So Terraform. You have to specify the bar file. Okay. Terraform, sorry. So what it does, it will show me, if you look at the screen, it will actually give you an overview of what will be created here. So now we will try to apply. Okay, so this is the plan, and we will try. Remember, I mentioned is the plan. So it shows me what are the plans. So like here, you can see one master and 3 worker node. Now all I have to do is apply this particular plan to initiate the deployment. Okay, now it will ask me whether to proceed or not. Okay, so everything will be automated. I don't have to do anything. If you will look at the screen, it's now creating the master node, the worker node 1 and 2 and 3, and then it will initiate the deployment and in the system. So if we go back here and refresh, now you can see it's creating the system. Can you see? Automatically, I don't have to do it. Meaning, I can create a cluster, Babi-san, in just less than 1 minute. Can you see how much time you save? Although sometimes it just takes so many time because it still have to start up the machine. That's why you can see here, it's still under maintenance because it's still loading. And if we go back to the script, I will put it side by side here. It's waiting, it's still creating. That's why it's still showing here in the maintenance mode. Okay, so this is automatic procurement, and you can confirm one core of CPU, 100 gig of RAM, and 100 gig of storage, and 2 gig of RAM, which is exactly what we deploy the plan. And now you can see one of the nodes is starting now. It's getting green. It's getting green. Master node is still yellow, meaning it's still loading. And now it has started also. So we have our cluster in probably less than 1 minute by using the Terraform. This is the platform. And by the way, Terraform, you can use it for free, Babi-san. So you can automate all your server deployment by using the Terraform. Now, what is the good thing? This is only for procurement of the server. Let's process. Now it has also applied and completed. Okay.
Okay.
Now, how about creating the cluster? After you create the deployment, it will actually create an inventory of file. Let me show you. So there is an inventory file created, which is the summary of the servers that you have. Let me just show you the file here. So this is the host. It shows you the IP address where they are deployed. Now we can use this to deploy the Kubernetes cluster automatically also. No need to manually set up the cluster. Let me show you that. Okay. So, but first, before that, we will try to actually verify that we can actually connect to the system. Okay, so let's try to ping. Okay, so we were able to successfully ping, meaning the system can actually connect to all the nodes. That's why you can see here success and success and success. Okay,
Okay.
that's the part. That's only for the hardware setup. We can automate and very fast. Now, how about I want to create a cluster? Since we already have the inventory file, now we can also automate creating the what we call the cluster. We can let me demonstrate that by using the Ansible playbook provided by CubeSpray. So let me show. So remember, we will use the inventory file that has the cluster information. And I will automate creating the cluster by using this. Okay. Can you see? The Ansible playbook is doing everything for us from deploying the cluster, connecting all the nodes. Everything is being managed. I don't have to do anything. All are scripts, meaning I can automate everything. So meaning I should have been able to create a cluster by in less than 5 minutes. But it depends also on how fast your virtual machine, like in my case, it's very one single core CPU. That's why it's very difficult to actually make it fast. So it might take so much time, Babisan. Okay. Now, this will take maybe approximately 10 minutes. So I will actually just skip this part, Babisan, because I have already prepared another setup wherein we will deploy the Hyperledger Fabric. Okay, so I will cancel. But let me demonstrate first. If you look at the right side, this is our URL. On the left side is our node, right, from the server. See, if I want to destroy my cluster, how easy is it? Very easy also. Let me demonstrate. Now, the reason why I'm putting this side by side, Babisan, is you can see the left side where the servers are running. You can see how it changes the status. And on the right side is I will ask Terraform to shut down everything. Okay, let me demonstrate. Okay, very easy. A single command to just destroy using the Terraform. Now I will proceed with yes. Can you take note of the left side? It says maintenance, and it changes the status to the orange.
Right.
Okay, that means it's shutting down. It's shutting down, and I don't have to manually shut it down. You see, it's stop. Now, stop, and then it will actually remove that one until completed. Okay, now it's also showing stop. Now it's completed, and let me refresh. Server is gone. Very easy. Less than 15 seconds, server is clean. I don't have to manually do it. Everything is automated. Okay. Now, I just, one of the reasons is I'm showing this, Babisan, is you can use this one. Use the Terraform to automate all your server deployment. Do not waste time. Everything should be in script and should be automated. Okay. So we can use the Terraform is free to use. You can free to download, and you can use it to automate creating your servers and even your cluster. Now, let me show, because this particular server doesn't have any credit. It's just 12 cents now. So I created another cluster to demonstrate how to deploy Hyperledger Fabric in a clustered environment. Okay. So I have created another cluster, Babisan. So you're looking at the Kubernetes dashboard at the moment. And let me show you the nodes. So the nodes is this one. I have three nodes, 2GP, 2G2, and 2GL. Let me show that. Okay. Now, if I command, this is our Fabric server, and this on the left side is the Kubernetes node. Now, if I command, you can see it's the same node, like pool cluster 8W2G2 is the same on the left side. 2GL is also 2GL is here. 2GP is here also. What I'm trying to show you, this one is using the cluster node, and we will use this to actually deploy our Fabric. Okay, so let me just configure. So I want to make sure that okay. Now, one thing is I want to make sure that when I deploy the cluster, I should be able to connect to the ingress gateway. Okay, let me demonstrate that. So if I go here, let me just resize so you can see left and right side. So if I go to ingress services, I have an ingress controller here. This is what we call the gateway to the cluster. Now I have here the IP address. Let me just maximize a little bit. Okay, the IP address is maybe too small to see here, this one. 188.166.204.186. So we will set that in our configuration file so we can connect to that server. And we also use the net name. This is the namespace. The namespace is Fabric, and our endpoint address is 188, which is the same here, 166.204, and 186. Okay, now we want to deploy, but in this example, we only have three nodes, one CA, one peer, and one orderer, but it will be deployed in the cluster automatically and handled by Kubernetes. So that's why we set the endpoint address to 188 is the same as this one. Okay, now let's save this one. Now let's try to see here. If you look at the namespace, only two namespaces are available. We call it a default and the ingress. But in our configuration file, I added one more. Let me show you again. Namespace is a Fabric. This is because the reason why I'm showing this because I want to show you that we are actually deploying in the cluster, not on the local mode. Now I can also show you in our local machine, I already disabled the local Fabric. That's why you cannot see the Fabric anymore from here. You don't see the CA. You shouldn't see the order, which I showed you earlier. So now let's try to deploy into the Kubernetes cluster. Okay. Okay. So we will deploy. So there are several steps in the deployment. Again, what I'm showing you is also we automate Babisan by using the tool Minifab. Minifab is I am one of the contributor in the Hyperledger Labs. That's why I was added in the Hyperledger Labs. So it automates everything from generating, downloading the images here. It will verify all the options, like how many orders you have, how many CA, how many peers that you want to set up. Not only that, it also automate the generating of the certificates for you. It's still not communicating yet, but you can see here, there is now a namespace appearing, Fabric,
Fabric. Right.
but no services yet deployed. So if I filter,
Nothing
nothing yet because it's
at the
still
moment.
generating the certificate at the moment. But
Right.
I'm showing you left and right because I want to make sure I demonstrate to you that this is live, a deployment to a cluster, not manual. Everything is automated. So generating the certificate is first it generates the certificate for the root CA, and then it generates certificate for the orderer, the peers, and including the committing peers. So that's why it takes time. So don't worry, this is a very low virtual machine. I think I only have 2 gig of RAM. That's why it takes time. Now it's communicating to the uh, system. So we'll just have to refresh. I think you can see from refresh. Oh, you can see here, it's now
Right.
appeared. You have our orderer, we have our peer. Earlier, it's empty, right? Now you
Yes.
can see here, and you can see also the CA, the orderer. But this is in the cluster mode. One of the advantage if you're in the cluster mode is suppose the CA is down, system will automatically start a new CA without having to do it manually. The Kubernetes will maintain, make sure that whatever you define, it should be running in the system. It should maintain the deployment plan. So meaning it actually monitors the health. It actually monitors also the ping time. Make sure that your system is running all the time. Even if one of the system is down, it can actually recreate again. Okay. So here it's just starting the nodes. That's why it will give like 120 seconds. Although it can be completed below 120 seconds, but it needs to be waited just to make sure that all the services is running.
Mm-hmm.
So we'll just wait. I think just a few more seconds before script will complete. And although it in here it's already running, but system is forcing it to wait for 120 seconds, meaning 2 minutes to
Okay.
make sure that all the nodes are actually running.
Mm-hmm.
So now, if you look at here, Babisan, what I'm trying to demonstrate is not only you automate deployment of the cluster, you also automate deployment of the fabric network into the cluster.
Okay.
No more manual, no more manual procedure. Everything should be automated because time is very important. Make sure that our system is running.
Right.
Now it's creating the channel and it's generating the profile. The profile, you can see in the status, profile is it will generate the connection profile. So our API can connect to the network. All the configuration are already saved. Before, without the profile generation, you still have to check what is the IP address, what is the IP address of the CA, what is the IP address of the orderer, and then manually set up a connection profile and connect. Now, what it does is now it is installing a sample chain code. Make sure that not only we have the fabric running, but make sure that we can as well deploy some chain code in the system. So normally the chain code will take a while because not only before it install, it will first compile and then perform the initialization for the chain code and install all the dependency. The chain code in our example is written in Node.js. That's why it also requires some dependency that where the system will have to download. But the most important part is we don't have to do it everything manually. Our
Mm-hmm.
script will actually automate the downloading and deployment of the system. But as you can see here, we have the system running, health status is okay. We have created a channel. We have uh, created all the collection profile. It's just testing that it can deploy the chain code as well. Meaning, if your fabric network, Pavisan, you configured multiple peers connected to the channel, the script will also deploy to all the peers which belongs to the channel. So
I see.
automatically do that. Before, if you don't use the automation, once you deploy to one node in the channel, you also have to manually deploy across one by one. Right now,
Okay.
no, automatically including updating. So for example, if I have 10 peers in the channel, if you want to update the chain code to newer version, you have to do it manually, one by one. Now it will be deployed automatically, regardless how many nodes you have in the channel. Now it has completed the deployment of the code. It has already approved, and see, everything is good. Yeah, that's why there's no failure, and mini fabric is running, and you can see from here.
Okay.
Okay. Now, question: how easy is it to actually clean up if I don't want to run my fabric network or remove? Very easy, Bobby said. One single command, I can clean this up without any problem. Let me demonstrate. So using the minifab, I can do clean up and just observe what will happen. Sorry. Minifab, not minfab. Okay, so it's the same step. It performs verification. Again, I'm showing this because we're automating. That's why you can see here, it's verify the options, meaning what are parameters that we need to uninstall. Now it is shutting down, and you can see here, disappear
Okay.
automatically. So before everything, it takes you like how many hours to clean up, to deploy, to install chain code, to upgrade chain code. Now it will just take you like probably sometimes less than a minute or maybe less than 5 minutes. Now it's completed without any error. Everything is using the script and using the mini fabric tool to deploy on the local cluster or to deploy in a cluster mode. Very easy. Everything is automated now.
Okay.
Okay, so that's what I'm trying to show, how to automate cluster deployment, how to automate provisioning of nodes, how to deploy in the cluster, how to clean up how to deploy a fabric into a cluster. Because I think so far, Babisan, this is probably the first time that you have seen a fabric running in a cluster, right?
Right.
Now
That's
we
right.
can also, so you can also automate how to clean up the cluster, and very easy. And also, just like in Terraform, if you want, after you provision some servers, if you want to clean up, as easy as a single command, the script will actually automatically do the cleanup for you.
Understood.
Okay. Let me stop the recording first.
Yeah.